Hello students, good evening. So we are going to look at the third session in laws of motion, and this is a very important session. In this session we are going to discuss about the idea of what we call as a free body diagram. So in all Newton's laws of motion problems we are going to look at this concept of free body diagram. This is why we all problems solve. Okay, so this is a very important session. Correct, the idea the free body diagram draw okay, so if you are able to get that idea, means most of the problems in the laws of motion, right, they are like half solved. And the free body diagram, if you are able to draw correctly, means it's like half the problem is solved. Okay, ba? So we'll start the discussion. So first we'll start the discussion with the free body diagram. So this is the Newton's laws of application, right? Whatever problems we have based on the applications of Newton's laws, they're all going to begin with this free body diagram. First, in the free body diagram we'll try to understand. Okay, we'll see how the free body diagram will be used while solving problems. See, free body diagram, it's a very simple idea. See, when you are looking at an object, it is connected to various other entities. So, a block of mass, generally it is either connected to a rope, or it is on some surface. Like that, you have various connections for the object. Connections on we're talking about the physical connections here. Okay, if you take that body, whatever the object you want to study, so in the object nama study panna porom, and the object mattum edutittu represent that object with forces acting on that. And the object ku mela enna forces irukko, and the forces ella nama represent pannum without missing anything. Okay va? Without missing anything, and the object mele all forces நம்ம represent பண்ணணும். And we should remove all the physical contacts. You will see that there will be some physical contacts. Either it is in contact with some other object, or it is connected to the rope, or it is connected to the string. It is connected to the rope, it is connected to the rope, or it is connected to the spring. You will have some physical connections. And the physical connections you just represent only the forces acting on the object. Apdi represent panna, you will call it as a diagram. Adukku in the free body diagram. So what do we call it as? Free body diagram. So free body diagram enna theriyuma? It's a very simple idea. Any object you want to study, and the object ku mele irukra ella forces nama represent pananum, including the direction part. In the direction irukku solittu adiyum nama correct represent pannom. Represent pannittu we should just remove all the physical contacts. Veru on the object mattu nama paakra madiri varum. So we will just focus on that object alone with all the forces acting on the object. Appo enna theriyuma? We can clearly understand what are all the forces acting on the object, and based upon those forces, what will be the net force acting on the object or what will be the change in the motion of the object. Adella nama study panna mudiyum. Okay, so what will be the effect of the forces we can study more focused when you see the free body diagram of any object. Okay va? So adukku we'll start with very basic example. Enga parunga, let us say there is a block or book. Okay, so the book kan edukonga. Okay, so there is a book of mass m which is kept on the table. This is the table. Okay va? So there is a book of mass m. The book you can take it as a block or whatever it is. Generally we will use this word block very much. Okay, so take this book of mass m which is on the horizontal surface of the table. The book is on the horizontal surface of the table. Okay va? Now the question is, can we draw the free body diagram of the book? Edukku nama indha free body diagram draw pannum? We should draw the free body diagram of that book. Okay va? So adukku namakku enna venum? We should know what are all the forces acting on the book இங்க பாருங்க. So let us say we will represent the book. ஓகேவா, அப்படியே அந்த ஆப்ஜெக்ட் அப்படியே ரெப்ரசென்ட் பண்ணணும் first. Then we know every object will experience weight. Okay, so weight of the object, if the object is or symmetric irunda, then what do we say? The weight will be acting from the center of the object. Angle and the weight weight will be acting on the center point. Okay, so generally we will represent the weight by the symbol W. What is the value of the weight? M into G dana. What is the value of the weight? M into G. Okay va, adu mudinjadu, weight is over. Then inga parunga, this is in contact with that block. Is in contact with the block. Okay va, so if it is in contact with the block, and the contact la nama paathirukom, when there is a contact between two surfaces, there will be two forces which will exist due to that surface to surface contact. And the surface to surface contact irukadanaala you will have what? Two forces. One is what we call as normal reaction. Normal reaction dana. Rendavadhu enna? Friction. But நம்ம already சொல்லிருக்கோம், friction பத்தி we will discuss about it later. Friction எப்போ வரும்? When the surfaces are rough. So here we are not mentioning anything about the roughness of the surface. அதெல்லாம் நம்ம மென்ஷன் பண்ணலாம். So we assume that we are not discussing about the friction force. ஓகேவா, so வெறும் இந்த normal reaction மட்டும் இருக்கும். So on this book, what will be the normal reaction? நாம வெச்சுக்கோங்க, what is the normal reaction we discussed? From that contact surface, normal reaction will be always normal to the contact dana. Normal reaction will be always normal to the contact. And then surface, contact surface லந்து it will be normal into that object. இப்போ நம்ம எதுக்கு மேல நம்ம normal reaction measure பண்றோம்? We are measuring the normal reaction acting on the book dana. Means from that contact surface it will be perpendicular or normal to the contact surface. Normal இருக்கும். Normal சொன்னா என்னது? Vertical தானா? ஏன்னா contact surface எப்படி இருக்கா? Horizontal. So normal reaction எந்த பக்கம் வரும்? It will be what? Vertical. ஓகேவா, it will be perpendicular or normal to the contact surface. And we are looking at the normal reaction acting on the book, means it will be into the book. So paranga, the second force acting on the book will be what? Normal reaction. Avladana. Is there any other force acting on the book? Idhukku mela edavadhu force irukka? We don't have any other forces acting on the book. So there are two forces acting on the book. Enanade? One is the weight of the book, and the book oda weight, which will be always vertically downwards. எங்க நம்ம ரெப்ரசென்ட் பண்றோம்? weight will be always for a symmetric object. Symmetric இருந்தா then we will represent the weight on the center of the body. Okay, ஒரு asymmetric object or non uniform object ன்னு வெச்சுக்கோங்க, then no, we are going to have weight represented at some other point. அது நமக்கு இந்த சாப்டர்ல வராது. It is going to come in another chapter called as what? System of particles. அதுல நம்ம அந்த asymmetric object, அந்த asymmetric object ஓட இதுல where the weight will be acting, so we will call the point as what? Center of gravity and சொல்லுவோம். அதெல்லாம் we will discuss it when we go to that particular chapter. But இங்க என்ன, we will generally have இந்த மாதிரி book block அந்த மாதிரி symmetric objects தான் இருக்கும். So we will represent the weight to be acting at the geometric center of the particular object. பாருங்க, we are representing at the geometric center. அதுக்கப்புறம் we have one more force acting on the book. என்னது? Normal reaction தானா? So normal reaction will be what? Perpendicular to that contact surface or normal to the contact surface. Okay va, இவ்வளவுதான். So this diagram is what we call as the free body diagram of the book. என்னது? We call it as what? The free body diagram of the book. புரியுதா? So this is what will be important if we want to study the motion of that book or the properties of the book by using Newton's laws, right? நமக்கு என்ன வேணும்? Free body diagram வேணும். So we should first require what? Free body diagram of that object. And the free body diagram ல இருந்து தான் we are going to see how the forces are going to affect the motion of the object. Okay va? We will look at one more example. இங்க பாருங்க, here I am giving you two objects. என்னன்னா, it's like there are two blocks ன்னு வெச்சுக்கோங்க. How many blocks are there? There are two blocks. There is a block A, there is a block B. So இதுலயும் அப்படிதான், we are not talking about friction. Friction பத்தி நம்ம பேசுறது கிடையாது. Okay, we are not going to talk about the friction. Question anna, draw the free body diagram for the block A. So there are two blocks here, block A irukka, block B irukka. We should draw the free body diagram for the block A, and we should draw the free body diagram for the block B. Okay, so look at this students. First, edukku nama draw pannalam, block A draw pannalama. So look at this block A. Okay, adoda weight WA and solala. So every block will have its weight. Every block, every object will have its weight. Okay, adukaprom vera enna contacts irukka? Block A is in contact with the surface of the block B. Paranga, block A is actually in contact with the surface of the block B. Appo enna varum? Normal reaction varum. We are looking at normal reaction acting on the block A dana. Block A mela, what is the normal reaction acting? Adu eppadi nama measure pandrathu? From the contact, on the contact surface lende it will be into the block A perpendicular to the contact surface. Okay va? It will be into the block A perpendicular to the contact surface. Paranga, eppadi nama represent pandrathu? It will be what? Normal reaction. So it will be what? Perpendicular to the contact surface into the block A. So these are the two forces acting on the block A. So why are we calling it as N1? Na solra. Okay, because we are going to have one more normal reaction here. Because we are going to draw the free body diagram for the block B also, right? Adila we are going to get one more normal reaction. Adukada nama use pandrom. We are using the symbol N1 for this normal reaction. Mudinjide. This is what is the free body diagram for the block A. Okay. In the diagram based panni, we can study the motion of the block A. We can study the motion of the block A based upon the diagram. Okay va? Now we will try to draw the free body diagram for the block B. Block B oda free body diagram. Paranga. We are trying to draw the free body diagram for the block B. Okay. So already there is a clear indication. They are saying what? There is a force F acting on the block B. The block B mela there is a force acting on it. Apdiye and the force varum. So there is a force acting on the block B. Adukapram enna varum? Block B will have its own weight. Adukena we'll call it as WB and solalama. Weight of block B. Okay. So if the mass of block A is MA and mass of block B is MB, then what will be the weight of block A? Adena varum? MA into G. And the madri weight of block B will be what? MB into G, because weight will be equal to what? Mass of that particular object into acceleration due to gravity. Adana. Adukapram, what are the other forces? Nama careful paakano. Enna if you are missing one force anna avladha, the entire problem will be gone. When you are drawing the free body diagram and the free body diagram draw pannumbodhu, if you miss even one force, the entire problem is gone. Paranga, we said A is in contact with B, then it is like what? B is also in contact with A. When A is in contact with B, B is also in contact with A. This is that contact surface. Then there will be a normal reaction acting on A because of B. Adha nama measure pannirukkom. N1 and solita. Based on the Newton's third law, for every action there is an equal and opposite reaction dana, which means there will be a normal reaction acting on B also, which will have the same value but opposite direction. Inga paranga, if we want to measure normal reaction acting on B, eppadi adu measure pandrathu? Normal reaction will be normal or perpendicular to the contact surface, and we are measuring the normal reaction acting on B. We are measuring the normal reaction acting on B means what? The normal reaction acting on B will be into the B, and the contact surface length it will be into the B, right? So eppadi varum paranga, it will be what? Downwards. In the direction it will be what? Downwards. Okay va? So the value will be what? Same N1. So this is the A to B oda surface. Angalandu it will be what? Already then this is the weight. Okay va? From the contact surface, then this is the AB oda contact surface. This is what AB oda contact surface. On the contact surface length, the normal reaction will be acting into that B object. So here we are measuring the normal reaction acting on the B. So the normal reaction will be acting into the B. But based on the Newton's third law, right? normal reaction acting on A is N1 means normal reaction acting on B also will be what? Same magnitude, N1 da irukum. Okay va? So is it over or we have any more forces? Carefully paranga. The B block, right, is also having one more contact. Enga iruka? The B block is in contact with the table. Irka illaya? The B block is in contact with the table. Paranga. Block B is in contact with the table. Okay. So here also there will be a inga enna varum? Because there is a contact, there will be a normal reaction. Normal reaction varum. Now we are measuring the normal reaction acting on the B dana. Means on the contact surface lende we should look at the normal reaction which is into the B, because we are looking at normal reaction acting on the B. Idhukku enna theriyuma, we will use a different value. Ena this normal reaction is different, right? Idhukku munna nama paathathu enna? Normal reaction between the A B surface. Inga enadhu? Normal reaction between the B and the table surface. And rendu surface nadula. Okay va? So look at this. There will be one more force acting on the block B. Adanade, this is a different normal reaction. This is a normal reaction between the block B and the surface of the table. Endha rendu nadula? The block B and the surface of the table. And the rendu nadula, this is a normal reaction. Okay va? So this is about the total number of forces acting on the B. Paranga, on A, how many forces are acting? Only two forces. Enanade? The weight of that block A, adukaprom the normal reaction between the A and B surface. So okay va? So that is the number of forces acting on the A. Adella nama represent pannirukom. Idhula the free body diagram for the A. Okay, so this is the free body diagram for A. Idhilande we can study the motion of A. Adukaprom enna, we are drawing the free body diagram for B. On B, how many forces are acting? Totally 4 forces. Enna? Clearly they are themselves representing one force F. Okay, adukaprom B will have its own weight and there will be 2 normal reactions. Okay va? So na thaniya represent and the normal reaction mattum na represent panna paranga. Okay, so this is B. There will be a normal reaction at the contact surface between A and B. Adu eppadi irukum? Wherever you take the normal reaction acting on a body will be always into that object. Okay va? On the contact surface it will be into B. This is the N1. Adukapram there is one more normal reaction between and the B oda surface and the table surface. Okay, adukena nama value edukrom N2. Namakku theriyadu values theriyadu. N1 oda value namakku theriyadu, N2 value theriyadu. Okay, but we are generally representing this by what? A symbol N2. Okay va? Adu eppadi irukum? From inga da irukka contact surface. In the contact surface lende it will be into the block. Appadi varum. Okay va? So this is how we are going to represent the normal reactions acting at both the surfaces. Ena or object mela if there are multiple contact surfaces, right? One contact surface edathila we have to be carefully choosing the normal reaction or direction. Okay, so this is what is the free body diagram for the block B. Okay va? So another example paakalam. Look at this. So neenga try pannala, like you can try this question. If you are not able to do it means I will give the solution. First in the question mattum paranga, draw the free body diagram of the mass M. This already in the representation I'm already paathirukom. Enga the force because of a spring on the discussion la. Draw the free body diagram of the mass M. Edukku nama draw pananum? The mass M ku nama draw pananum connected to the elongated spring. Enadhi? Spring is what? Elongated. Elongated enna theriyuma? The spring will be having restoring force. Spring nama expand panna illana compress panna, then what is going to happen? The spring will start creating a force. Adukku nama enna solluvom? We call it as what? Restoring force illana resistive force nu solluvom. Appadidana we call it as what? The restoring force or resistive force. Paranga. So enna nama draw pananum? We have to draw the free body diagram for the mass M. Okay, check pannunga. So you just take some a couple of minutes try pannunga. Illana I will anyway give the solution. Okay, obviously you cannot type the answer in that chart la neenga type panna mudiyadu, but you can at least mention enna force on the mass M ku mela act agum solittu. You can mention what will be the forces acting on the mass M. what will be the forces acting on the mass m? இங்க பாருங்க, mass m மட்டும் நம்ம எடுத்தா definitely any object will have its own weight. அதோட weight இருக்கும். That is what mg downwards. ஓகேவா? அதுக்கப்புறம் என்ன சொல்லிருக்காங்க, the spring is elongated ன்னு சொல்லிருக்காங்க, which means what, spring force. இப்போ நம்ம spring elongate பண்ணா spring will try to pull us in, அப்படிதானா? so spring force already இந்த diagramல இருக்கா. spring force எப்படி act ஆகும், it will be trying to pull the, so the spring is elongated means it will try to pull the mass இந்த பக்கம். like in this particular diagram எப்படி வரும், this is the left, spring force will be acting left side. ஓகேவா? அதுக்கப்புறம் வேற என்ன வரும் பாருங்க, there is a surface to surface contact. என்னது, the surface of the table or whatever it is below and the surface of the block m, there is a contact. இந்த எல்லா ப்ராப்ளம்ஸ் என்ன தெரியுமா, we are not considering frictions. அதை நீங்க ஞாபகம் வச்சுக்கோங்க, because we are going to talk about the friction and the friction based problems separately. first என்ன தெரியுமா, we will consider that all the contact surface, எங்கெங்க அந்த கான்டாக்ட் இருக்கோ அதெல்லாம் நம்ம என்ன அஸ்யூம் பண்றோம், we are assuming it to be what, smooth surface. this is the assumption. okay, smooth surface இருந்தா then there will be no friction when there is a contact between two surfaces, right? two forces will be acting due to that surface to surface contact. one is normal reaction which will be acting normal to that contact surface. ரெண்டாவது friction. எப்படி act ஆகும், friction will be acting parallel to the contact surface. friction will be acting parallel to the contact surface. ஓகேவா? எப்போ வரும் friction, when the surfaces are actually rough, which is normally the case. theoretically தான் அந்த smooth surface இருக்கும், practically நீங்க எந்த surface எடுத்தாலுமே you will be able to see that there will be some amount of roughness. ஓகேவா? but here because we are solving some theoretical questions, என்ன நம்ம assume பண்றோம், we are assuming that the surfaces are what, smooth. okay, so இந்த நம்ம friction consider பண்றது கிடையாது, we are not considering the concept of friction. ஓகேவா? so பாருங்க, there is a contact between the mass m and the table, so அதனால there will be a normal reaction. இருக்குமா இருக்காதா, there will be a normal reaction. so how the normal reaction will be acting பாருங்க, from that contact surface, and the contact surface ல இருந்து it will be acting in what direction, we are measuring the normal reaction acting on m, right? so on the contact surface ல இருந்து it will be perpendicular to the contact surface into that object. எந்த object மேல நம்ம அந்த normal reaction எடுக்கிறோமோ that normal reaction will be measured always into that object. இங்க என்னது, we are measuring the normal reaction on the block, so normal reaction will be taken into the block. ஓகேவா? so இதுதான் normal reaction n. பாருங்க, so there will be a normal reaction force. so as per the diagram, right, the normal reaction is coming in which direction, vertically upwards வருது. ஓகேவா? so normal reaction is coming in which direction, vertically upwards. இதுதான் the free body diagram for the block of mass m. ஓகேவா? so எத்தனை force இருக்கா, the block of mass m is having how many forces, 3 forces. என்னென்னது, one is its own weight, அதோட weight. அதுக்கப்புறம் the force because of the spring, because spring is elongated னு சொல்றாங்க. so elongated சொன்னா என்னது, the spring will try to pull the block. pull என்னது, it is in this representation it is towards the left side வரும். ஓகேவா? அதுக்கப்புறம் there is a contact surface between the block and the table below, அதனால there will be a normal reaction. okay, so இதுதான் free body diagram of the block. அதுக்கப்புறம் இங்க ஒரு ப்ராப்ளம் பாருங்க, இதுல என்ன, a cylinder of weight w, cylinder of weight என்ன w, is resting on a v shaped groove. எப்படி இருக்கா பாருங்க, so the groove is like what, ஒரு v shaped இருக்கா, the groove is like what, it's like a v shaped groove. ஓகேவா? draw its free body diagram. எதுக்கு, they are asking for the cylinder. பாருங்க, we are looking at the side diagram, side view. இது என்னது, side view நம்ம பார்க்கறோம். ஓகேவா? so cylinder இப்படி சைடா பார்த்தா எப்படி, it look like a circle மாதிரி தானா, so we are looking at the side view of the cylinder. ஓகேவா? so இந்த cylinder ஓட free body diagram நம்ம draw பண்ணோம். check it students, எப்படி வருது, cylinder they are clearly saying அதோட weight எவ்வளவு w அப்படியே நம்ம represent பண்ண போறோம் because the weight will be acting vertically downwards முடிஞ்சது. so we are representing the weight. அதுக்கப்புறம் carefully பாருங்க, the cylinder is contact in this v shaped groove. எங்கங்க இங்க ஒரு கான்டாக்ட் வருது, அந்த மாதிரி இங்க ஒரு கான்டாக்ட் வருது. so the cylinder is having how many contacts with that v shaped groove? 2 contacts. ஓகேவா? so இங்க ஒரு நார்மல் ரியாக்ஷன் வரும், இங்கேயும் ஒரு நார்மல் ரியாக்ஷன் வரும். so how many normal reactions we are going to get? We are going to get 2 normal reactions. ஓகேவா? so this we can say normal reaction 1, idanadu we can say normal reaction 2. so always normal reaction will be what? on the contact surface la it will be what? perpendicular. inga parunga idu appadha perpendicular, and we are measuring the normal reactions acting on that cylinder. so normal reaction eppadi irukum? It will be into the cylinder nama edukku porom. okay, so we'll take the normal reaction into the cylinder. so eppadi varudha parunga, we will look at the weight will be what? acting downwards. okay va? and madri there will be a normal reaction here in the direction la, it will be from that contact, and the contact length it will be normal to the contact acting into the cylinder, because we are measuring the normal reactions acting on the cylinder. okay va? and madri inda pakka parunga, there will be one more normal reaction, inge or contact iruka, there will be one more normal reaction here. It will be what? normal to the contact surface. okay va? this will be also into the cylinder. so this is the free body diagram of the cylinder. okay, so neenga or observation panna you will know one thing, because when the cylinder is touching, idukku enna theriyuma, what do we call it as? This is what we call as the tangential and solluvom. what do you call it as? tangential. so already nam and 2D motion circle oda edu pathi nama discuss பண்ணும்போது we talked about it, tangential. okay, tangential க்கு perpendicular னு சொன்னா என்ன தெரியுமா? what is perpendicular tangential? இது நம்ம என்ன சொல்லுவோம்? we'll say radial னு சொல்லுவோம். so radial, நீங்க அந்த டைரக்ஷன்ல போனா என்ன வரும்? you are going to get the center. you go in the radial direction, என்ன வரும்? you are going to reach the center. பாருங்க, so the normal reactions also will be in the direction which is going to go through the center. so normal reaction also will be in the direction which is going to go through the center. எதனால? because the contact surface is tangential, அதுக்கு perpendicular னு சொன்னா என்னது? radial தானா? so the normal reaction will be along the line which is going through the center of that, and the cylinder oda circular face irukku theriyuma, it will be going through the center of the circular face of the cylinder. okay, so idha and the cylinder oda free body diagram. so ipdi and the free body diagrams varum. so this is important. the free body diagram la we are going to go to the applications of the Newton's laws. so whenever we want to study the motion of a body, first step enna theriyuma, we will draw the free body diagram, illana in short what do we call it as? FBD. okay va? and the FBD draw பண்ணதுக்கு அப்புறம் we will start studying the motion. FBD draw பண்ணா we will know clearly without ambiguity. ஏன்னா இந்த physical connections இருக்கும்போது என்ன தெரியுமா, we will be always little bit confused. எங்க force வருது, எங்க force இருக்குன்னு சொல்லிட்டு அதோட direction எல்லாம் confusing இருக்கும். if you remove all the physical connections, வெறும் அந்த forces மட்டும் நம்ம represent பண்ணா, we will be able to clearly see what are the forces acting on the object, எந்த direction இருக்கா, அது எப்படி we will be able to see the total effect of all the forces in a clear manner when we draw the free body diagram. அதுக்கு தான் இந்த importance. okay va? now we'll look at one more example. this one all of us should get it. பாருங்க, a block of mass m is attached to 2 strings. 2 strings இருக்கா as shown in the figure. எப்படி? this is the block. okay, இந்த பக்கம் ஒரு string, இந்த பக்கம் ஒரு string. there are 2 strings. draw the free body diagram of the block. என்ன நம்ம draw பண்ணணும்? we should draw the and the block or the free body diagram. take some time to draw. so first என்ன தெரியுமா, we will look at what are the contacts that are there for the body and the block. here we are looking at the block, right? இதுக்கு என்னென்ன contacts இருக்கா? இந்த பக்கம் there is a rope, which means what? there will be a tension which will be always, remember what is it? tension force will be always acting into the rope. okay va? because always the rope will try to, so ஏதாவது object if you connect it to a rope will always try to pull the object. rope cannot push. Yeah, rope means what? Can the rope push? Rope cannot push. Rope எடுத்துட்டு we will only be able to pull the object. So if you are connecting any object to the rope, tension force acting on the object will be always what? It will be always into the rope. Tension force acting on the object will be always what? Into the rope. Okay va? அந்த மாதிரி இந்த பக்கம் பாருங்க, this is also connected to one more rope here. So இதுல என்ன? Tension force will be acting into this rope. So இந்த பக்கம் ஒரு tension force இருக்கும், அந்த பக்கம் ஒரு tension force இருக்கும். Because remember, if you look at a rope, if you have a rope which is massless, if you have a rope which is massless, நம்ம ஆல்ரெடி என்ன சொல்லிருக்கோம்? Tension in that rope everywhere. If you have a rope which is massless, tension in that rope everywhere will be what? Will be same. Adana, if you have a rope which is massless, tension everywhere in the rope will be same. But here this is a rope and this is another different rope. ரெண்டு ஒரு rope கிடையாது. This is a rope and that is another different rope. So இதுல ஒரு tension value இருக்கும், அதுல ஒரு tension value இருக்கும். ஓகேவா? So this is what அதுக்கு அப்புறம் என்ன இருக்கும்? There will be of course on the block oda weight. There will be the weight of the block itself. ஓகேவா? So பாருங்க, what will be the free body diagram எப்படி நம்ம represent பண்ண போறது? I'm sure you would have got the answer. So எப்படி வருது பாருங்க, the block will have its own weight which is what? Mg, and there will be a tension into this rope. அதானது T1 னு சொல்லலாம், because we don't know what is the tension force. Tension force, like we know what is the weight. Whichever object you take, what will be the weight of the object? The mass of the object times acceleration due to gravity. Okay, but tension appadi kadiyadu. Tension will keep changing even though there is a rope, and the rope kulla what will be the tension value? Because paranga, if you just slightly try to pull the rope, you will have some tension. Ingonjam force vechi pull panna, the tension in the rope will become what? Increasing. So the rope becomes stiffer and stiffer, means adhula tension value also will be what? Increasing. So tension evolu nu solittu we will not be able to tell it. Okay, it can change. And the in the bakana, this is another rope. So there will be one more tension acting in this direction. Okay va? So this is what is the free body diagram of that block. This is what is the free body diagram of that block. Okay va? So this is how we are going to draw the free body diagram of the objects. Idhilanda we will be able to easily study. Idhilanda we will be able to study easily the motion of the object by applying the Newton's laws. Okay, but before we go and look at the applications of the Newton's laws, we will try to do little bit more study on the assumptions we make on the rope and pulley. We are going to talk about one more object called as pulley and solita. What is it called as? So what is a pulley? Generally, like if you go to a old well, then you will see that when you are pulling that whatever the vessel from the well, right, you will see that the rope, so the rope will be going across a wheel. You will be standing here and trying to pull the rope, and the bucket that will be attached to a bucket of water or something which will be put into the well. In the bucket and pull panna, you will see that the rope will be moving across the pulley. The rope will be moving across the pulley. So whenever a rope has to move, right, எப்படி ஸ்மூத்தா மூவ் பண்றது? We will use this object called as what? Pulley. What is the object we use to move the rope smoothly? It is what? A pulley. Okay va? So whenever we look at these systems in Newton's laws of motion chapter, we will very commonly see blocks, and the rope, and the pulleys. These are very common entities. Okay, so what is the main purpose of the pulley? The pulley will be able to move the rope across. Like practically, like you think about that old well that people use to drag water from the well, right? They will try to pull the rope across that wheel. The wheel puller, there will be some groove like thing will be there. The rope will be going across. So when you pull the rope, the pulley will be rotating. The pulley rotate agum. The other side rope will also keep coming up. And the bakka it will be coming up. The bakka we will try to pull the rope down. So remember how do we do it? We will try to pull the rope down this side. the rope from the other side will keep coming up. So the bucket of water or something from inside the well also will come up. Okay va, idha pulley and solluvom. Okay, so this rope, pulley and blocks, these are very common things that we see. Neenga endha problem edutha paathale, like you will see generally enna irukum, you will usually have a block irukum, illana you will have a rope connected to a block, illana you will have these pulley systems and solluvom. So wherever the pulleys are coming, we will call it as what? Pulley systems. Okay, but we are going to first look at some assumptions in the rope agatum or the pulleys agatum. We will make some assumptions for them. Okay, based on the assumptions, right, we will be having some results. Based on the assumptions, we are going to have some results. Okay, those results are important for us when you are solving these problems using Newton's laws, right? These assumptions and other corresponding results are important. Illana, it will be difficult to solve the problems. So first we'll start with the idea of connected or constrained motion. Okay, idhila da nam andha alla assumptions ella paaka porom. Okay, so what do you mean by the connected or constrained motion? Okay, so if paranga, if you take two blocks which are connected by a rope, okay, which is inextensible. Paranga, what is it? If you are connecting the objects by a inextensible sonnanade, they cannot extend the length of that rope, and the rope oda length nam extend panna mudiyadu. Okay va, if you connect two objects like that, what is going to happen as a result of it? If you connect two objects by a rope which is inextensible, generally enna theriyuma, the moment we use the word string or rope like that or a wire, we consider that the rope or the string agatum or that wire, they are what? Inextensible. So carefully paranga, it is spring kadayadu. What is it? String. Okay va. So when you have a string or a rope or a wire, we generally assume it is what? Inextensible. Inextensible and sonna theriyuma, adoda length nammalaala increase panna mudiyadu. It will be having a fixed length. Okay va. Adanala what will be the outcome of this? If you assume that the rope is inextensible, what will be the outcome of this? First, before we look at the outcome, right, paranga, if you just move this block or delta x nama move panachkonga in a time delta t, okay, this also will, in the rope cannot be extended, so this also will move by how much? Delta x. Okay va. So in the delta x by delta t panna enna varum? Velocity varum. Inge appadana delta x by delta t panna velocity varum. So at any given time, in the block or a velocity, whatever it is, the other block also will have the same velocity. Illa enna agu theriyuma paranga, if the block in the front is moving very fast, appa enna agum? Rope we cannot extend. If it is moving fast means, remember, if it is moving, say pinnadu or block irka, munadu or block irka, if the block which is in front is going fast means what? The rope has to increase the length, right? Illana அது possible கிடையாது. Inga rope length increase பண்ண முடியாது, which means what is going to happen? The rope has to break. அவ்வளவுதான். But here, you know, we are saying they both are connected by a rope and rope is not broken. Aprinda, then what it means? With whatever the velocity or the speed the first block is moving, second block also is going to come with the same velocity, and the velocity da varum. Which means what? If the and the munadu irukra block oda velocity is increasing at a particular rate, pinnadu irukra block oda velocity also must increase at the same rate. Illa enna agum? If the first block is increasing at a more rate, so first block oda velocity, then the second block oda velocity, what is going to happen? After some time, first block will end up having more velocity than the second block. Then, you know, you either have to increase the length of the rope, illa the rope has to be cut. We are saying both are not the cases here. The rope is intact, appadiye irka, which means what? Whatever the rate at which the first block of velocity is increasing, right? Second block of velocity also is going to increase at the same rate. Rate of increase of velocity or rate of change of velocity. And sonnanadi, what is this rate of change of velocity? Acceleration dana. So whatever is the acceleration of that block M, the other block capital M will also have the same acceleration when these two blocks are connected by an inextensible string. Okay va? We are not saying always the accelerations. Acceleration we'll always think about it like a vector. In acceleration don't look at always the directions. I'll show you one more example. Okay, here we are more interested in the magnitude. Whatever is the block A order acceleration magnitude, block B, actually here you are saying block of mass small m and block of mass capital M. Okay, in the block of mass small m order acceleration, whatever the magnitude, the block of mass capital M or the acceleration magnitude also must be same. Okay wow? So this is a very important assumption. They will call it as connected objects and solve. So when you are connecting the two objects by a rope which is inextensible, then both the objects will have the same magnitude of the acceleration. Because if you connect them by a rope means they should have the same displacement in a given time. Then they will have the same velocities. And the rate at which the velocities changes, that also must be same. Illana, what is going to happen? Over a period of time, both the objects will end up having different velocities. That's possible kadayadu. So both of them will have the same magnitude of acceleration. Now I'm going to representation kamikra. Paranga. So here we have the pulley system. Paranga. So here there is this small m in the pakku capital M is on that side. So capital M we are considering it as what? Higher mass. This is higher mass. This is what? A lower mass. Intuitive if you are having a higher mass, and the higher mass like this capital M will be going down, small m will be going up, the movement across the pulley. Okay, so because these two are connected, like the way you think about this well no. So when you are having that, when you are standing, this is the pulley and this is the vessel. This is the vessel, okay. So in an you are pulling that. So the same rope is going across the pulley. Across the pulley, same rope will go. Okay, va? So both these small m and capital M, they are connected by the same rope, which is inextensible. Normally, whenever we look at a problems in Newton's laws of motion, right? Assumption the rope or string or wire, we assume it to be what? Inextensible. Adanala capital M is going down with some acceleration, then small m will be going up with the same acceleration magnitude. The magnitude of acceleration. So a total acceleration because acceleration is a vector which will take along with the direction. Okay, va? So the acceleration of the magnitude. So with whatever acceleration capital M will go down, small m has to go up with the same acceleration. Illana, the rope will either have to extend, illana the rope has to be cut. Because we are saying that the both objects are connected by a rope which is not cut and not inextensible. It means what? Whatever the downward acceleration of the capital M, which we are taking as A, the upward acceleration of small m is a lower mass. So lower mass will go up, higher mass will go down. The upward acceleration of small m will be having the same value. Okay, va? So what is this? This is a very important assumption. What is it? The assumption of inextensible string. When you connect two objects with an inextensible string, then the accelerations, if there are accelerations for the objects, means both the objects will be having same magnitude of acceleration. Okay, va? So this is an important assumption which we are going to be using. We will look at the assumptions related to the tension. Next we look at the assumptions related to tension. Idella clear because only when you are clear with the assumptions, right, it will be very easy to solve the problems. Illana will always be thinking, we'll always have that ambiguity. When you are solving a particular problem, we should be thorough in terms of the assumptions and we should be thorough in terms of the basic approach. Then any problem can be solved. we are talking about now the assumptions related to the tension. If a string is massless, so this is a string, so we are connecting the string with these two blocks. If the string is massless, the tension in it is same everywhere. Another, if the string is massless, the string is not having any mass, then what it means? Tension in that string everywhere will be what? Same. Okay. If a string has mass and it is accelerated, if a string is having mass and it is accelerated, this is a special case. This is not going to be coming always. Now maximum another string will be what? Massless, which means or rope or no or string or wire edutha adula wherever you look at it, tension everywhere in that rope or string will be what? Same, when you assume the string to be massless. Apadi illana, what is the situation? When the string is having mass and it is accelerated, then tension at different points will be different. Inge paranga. So here we look at this rope. We look at this rope, right? If you assume the rope is massless, a rope and solala, in a string and solala or wire, whatever you call it. If you assume that this string is massless, apadi nam assume panna, then look at it now. When you are drawing the free body diagram for the capitulum, paranga, capitulum is connected to the rope. There will be a tension force acting on the rope. Tension will be acting into the rope. Okay, va? So that we are representing by the value T. Then I am not drawing the entire free body diagram. Veru on the tension mattu we are looking at it. In the bakka paranga, we are drawing the free body diagram for the small m. We are drawing the free body diagram for the mass small m. Ingena varum, small m is also connected to the rope. Tension force acting on small m will be into the rope. Appadidana, tension force acting on any object will be always into the rope. So inge eppadi irukum? Into the rope and sonna like this. Okay va? And because the assumption is string is massless, everywhere in the rope, everywhere the tension will be what? Same. Means in the pakka, what is the tension going to be? It will be the same T, which means what? The tension force and the value acting on the mass capitulum will be numerically same as tension force acting on the mass small m. Edinala, because of the assumption we took. What is the assumption? The string is massless. Apdi illana theriyuma, if that is not the case, then in the pakka or tension value irukum, on the pakka or tension value. Because the rope tension force everywhere will not be same. So if you look at on one side, tension will have some value. Other side tension will be having some other value. Okay. So we are going to discuss in detail about how the tension in a string having mass will change. Okay. That is also like a problem. We are going to do it like a problem. But maximum anatharima, when we are looking at the problems that we solve, at least neat level of pathangana, we are going to be having problems where the assumption is going to be that the string is massless. Then what is going to be the outcome? Whatever the objects connected to one string, the tension force acting on the objects will be having the same value of the tension force. Okay, va? The tension force acting on the object will be having the same value. Okay. So this is an assumption in terms of the tension force. Mudila, we are going to look at some more cases. Okay. So this is the last and important one. Pulley assumption. Okay. So pulley assumption is also going to affect tension. Pulley assumptions is also going to affect what? Tension. So there are 3 cases we are going to discuss. Ethani cases? There are 3 cases. Rendu club panni. A string or assumption and then pulley assumption. Rendu club panni we are going to discuss about how many cases? 3 cases. First case, string, and this is the case which we normally see. This is normally paaka porom. Okay, so just remember this very carefully. This is normally paaka porom. Okay, string and pulley are massless. இங்க நம்ம எடுத்துக்கிற pulley and this string, this is the same string. பாருங்க, this is the same string. அப்படி அந்த string will be coming over the pulley அந்த அப்படி வரும். Okay, string and pulley are massless, both are massless, and there is no friction between the pulley and the string. The pulley or surface and string, right, there is no friction between them. Okay, அப்படி இருந்தா then பாருங்க, tension on this side of the pulley, ஒரே rope தான், one rope only, but tension on this side and tension on the other side will be same. Pulley எங்க வரும் தெரியுமா difference? Pulley will be creating a difference on tension on either side of the pulley. பாருங்க, so when you have a pulley, it will create difference on tension this side and tension the other side. இதில் நம்ம என்ன எடுக்கிறோம்? We are taking the pulley to be what? Massless, and there is no friction between the pulley and the string. அந்த assumption என்ன தெரியுமா? The tension on either side of the pulley, இந்த பக்கம் இந்த பக்கம், tension will be what? Same. And we are assuming the rope to be massless or the string to be massless, which means what? Totally this side the tension will be same, and the மாதிரி totally this side the tension also will be what? Same. அப்படி இல்லைன்னா then we are going to look at the case 2. Case 2 என்ன பாருங்க, string is massless, string mass கிடையாது, but the pulley is not massless. Pulley there is a mass. Okay, and there is also a friction. என்னது? புள்ளியோட assumption நம்ம மெயின் என்ன பார்க்க போறோம்? Whether the pulley is having mass or whether there is a friction or not. So first case என்ன? Pulley is massless as well as no friction. இதில் என்னது? Pulley is having a mass and there will be a friction. இதில் பாருங்க, இந்த pulley இந்த பக்கம் என்ன? Tension T1, இந்த பக்கம் tension T2, but இந்த சைடில் பாருங்க, எல்லா இடத்துல ஒரே வேல்யூ ஆஃப் டென்ஷன். Why? Because the string is massless. எல்லா இடத்துல இந்த பக்கம் left side like on one side of pulley tension is same everywhere, but on the other side, right, tension is same everywhere but the value is different. எதனால? Because that pulley is creating the difference. எப்படி வருதுன்னு சொல்லிட்டு we will be able to see when we go to the problems. Actually என்ன தெரியுமா, we will be able to understand this assumption clearly when we go to the rotational motion chapter. இப்போதுக்கு என்ன தெரியுமா, we will just try to remember this. இந்த assumption மட்டும் நம்ம remember பண்ணலாம். When we go to the rotational motion chapter, we will be able to clearly understand. ஏன் தெரியுமா, we have to discuss about the rotation of the pulley. அதுல இருந்து தான் எப்படி அந்த டிஃபரன்ஸ் வருதுன்னு சொல்லிட்டு we will be able to know. ஓகேவா? But for us here, we are just looking at the assumptions. போக போக you will be able to see how the assumptions can be understood by using the concepts of either the Newton's laws or the concepts in rotational motion. ஓகேவா? So இன்னொரு கேஸ் என்ன தெரியுமா, this is the final ultimate. String is also having a mass. Pulley is not massless and is having a friction between the pulley and the string. அது ஆல்ரெடி நம்ம கேஸ் 2ல பார்த்திருக்கோம். பட் கேஸ் 2ல என்ன இருக்கா, at least the string is massless. string mass கிடையாது. அதனால அந்த புள்ளி இந்த பக்கம் எல்லா இடத்துல டென்ஷன் இஸ் சேம், அந்த பக்கம் எல்லா இடத்துல டென்ஷன் இஸ் சேம், பட் the left side of pulley and right side of pulley அப்படி சொல்லலாமா? The one side of pulley and other side of pulley tension values are different. But இங்க என்ன இருக்கு பாருங்க, string is also having a mass. So both string and pulley are not massless, means they are having mass. String is having mass, அந்த மாதிரி the pulley is also having mass, and there is a friction also. இதெல்லாம் என்ன தெரியுமா, tension on left side of the pulley will be different from tension on the right side of the pulley. பாருங்க, இந்த பக்கம் என்ன T2, இந்த பக்கம் என்ன T3. Not only that, இந்த பக்கம் எல்லா இடத்துல டென்ஷன் சேம் வேல்யூ கிடையாது, டென்ஷன் கீப்ஸ் ஆன் சேஞ்சிங். பாருங்க, ஒரு இடத்துல டென்ஷன் வேல்யூ will be different. Why? Because the string is also having a mass. These kind of cases we will not see. We will see only in, அதாவது இந்த தியரிட்டிக்கல் மாதிரி questions வந்தா we will have, but we are not going to have numerical questions. Numerical questions எல்லாம் என்ன தெரியுமா, we are going to get only in this first very simple case. அதுல இருந்தா வரும். Okay, maximum when you get questions on this case 2 இல்லனா case 3, we are going to get only theoretical questions தான் வரும். அதுக்கு தான் நான் என்ன சொல்றேன், just understand the assumptions. Okay, so in the case என்ன தெரியுமா, like string is having mass, அந்த மாதிரி pulley is having mass and there is a friction between the pulley and the string. அப்ப என்ன ஆகும்? Tension on both sides of the pulley will be different, and at each and every point on the string tension is going to be what? Different. Okay va? So this is the case 3. Case 3 is the maximum difference varudha and the case la. So this is what we have as the standard assumptions and solla. What do you call it as? The standard assumptions for the pulley and the string. But what is it that we need to be focusing on the case 1? Ena nama numericals la enna vara porudhu? We are going to look at the case 1. Okay va? So these are the assumptions, but we will look at the applications, because while we are learning about the basic idea of inertia, adukapram we talked about the first law, adukapram we talked about the second law, adulande we have got the idea of conservation of linear momentum, then we come to the third law and we talked about the action reaction pair of forces, adukapram we talked about the free body diagram concept, then we looked at the assumptions that we are going to use. Ella நம்ம எதுக்கு பண்றது? We want to study the motion of objects. அதுக்கு தானா? We want to study the motion of the objects. இதுல sometimes we'll have simple objects. Simple objects என்ன தெரியுமா? The object which is in a simple arrangement. Okay. Sometimes we'll have a complicated arrangement. The complicated arrangement சொன்னா you'll have multiple pulleys இருக்கும், multiple ropes, அதெல்லாம் வரும். But whatever is the arrangement that you have, we are going to study all those things by using the Newton's laws. Okay, so why we are doing all the previous learning ella irukku theriyuma? To help us in studying the motion of the objects. And how do we study the motion of the objects? By using the Newton's laws. So we are going to get into the most important part of the chapter, the applications of the Newton's laws. What is it? The applications of the Newton's laws. So what we'll do is we'll start with the applications of the Newton's laws in the next class. Okay, இதுக்கு முன்னாடி என்ன தெரியுமா? We already did 3 sessions. நீங்க ஒரு தடவை பாருங்க, what are the things that we have covered in the previous 3 sessions. ஒரு assumption ஆகட்டும், or the cases that we discussed, go through them carefully, then we'll start off with the applications of the Newton's laws in the next class. Next class la we'll start with the applications of Newton's law. Okay va? So we'll see in the next session.